Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list. So the question that we will be discussing today is flattening of a linked list. So I'll just show you the problem statement quickly. Have a look here. Just give me a moment. Meanwhile, I'll just check if you guys are able to see my screen. I'll just explain you the question. I think yes, we are live. So I'll start off. Okay. Great. Okay. I can see the comments. It's live. So moving on to this problem statement. What is given here? You are given a linked list of size n. It's not a typical linked list or the ones that we see like a singly linked list. You can see it's something different. What is different in this linked list? That it has next node as well as it has some bottom nodes. Now your target is there is a pointer pointing to the next node, a bottom pointer to a linked list where this node is head. I'll explain each and everything. What you need to do is flatten the linked list such that all the nodes appear in a single level while maintaining the sorted order. Okay. So the flattened linked list will be printed using the bottom pointer instead of the next pointer. Now I'll explain you. Just give me a second. I'll just copy this and then I'll explain you what this question is. Fine. So as you can see, this is your test case. Fine. What you need to do in this question, that there is a linked list, right? For example, these links are the next links, okay, which is pointing to the next pointer. And these links, you can refer to them as bottom pointers, okay. So these are the bottom pointers and these are the next pointers. Now you have a linked list which contains any node. There is a node which has its own data, okay, and it is pointing to a next node. It has a next pointer as well as it has a bottom pointer, okay, something like this. It has a bottom pointer as well. This is your bottom pointer. Now your task is to convert this into a singly linked list such that all the nodes are in sorted order. Fine. So for example, if I look at it in this way, that initially my head is pointing to this link, this list, okay. So head dot next will be 10 and head dot bottom will be 7. Fine. If I ask you, so the intuition behind this problem is you can assume this is one linked list with bottom pointers like this. Or, let me take from the behind this. Let's assume this is one linked list and this is another linked list. Now let's try to flatten these two lists together. Then how is it going to look like? Have a look. If I just tell you that we have two linked lists, 28, 35, 40, 45, okay. Then we have 19. Why am I starting from backwards? I'll tell you. Just let's try to first understand what we are going to do. Now you know the next pointers, these are the bottom pointers, okay. Let's assume we have two heads. This is head A, which is pointing to 19 node, and this is head B pointing to node 28, right? Now tell me, we all have done questions like merging of two arrays, right? Here of sorted arrays, here what you have two linked lists and you have to merge them in sorted order. How would you do this thing? So as you can see, we have A pointing to 19, B pointing to 28. How merging can take place? Check which one is smaller out of two. If A, I am not writing exactly A dot data and all, just try to understand what my idea behind is. If I'm writing A is less than B, then obviously while I'm coding, it means A dot data is less than B dot data, okay? Because this is a linked list. So let's understand the basics. If A is less than B, then my point is I need to first store, let's take some other extra node, anything, it can be result, temp, we have taken result. So this is an empty node right now. What I want is which is a smaller out of these, 19. So right now maybe result is pointing to 19, okay. Result is right now pointing to 19. I have a node result, and right now I'll just update the result. Result is pointing to 19 as of now. Fine. Why? Because 19 is smaller out of these two. So now move your A to the next bottom of 19. A will move to, see, A is less than B. So maybe you will assign result pointing to A. Result is pointing to A. Now next thing what you want to do is you want to do the similar comparison. So basically this is my merge function, which is taking two data, which is head of one linked list and head of second linked list. Based on the comparison, I am making result point to that node, and then I'll do further merging based on which one is smaller and the comparisons. If, let's come back to it, if A was smaller than B, now my comparison should be between A's bottom and B was already present at 28. So let's compare 22 and 28 now. So for that I should be moving my A to bottom pointer. So A should become A dot bottom. Okay. And then you are calling merge function again for new updated A and your previous B, right? Now your merge function is being called for 22 and 28. Fine. Simultaneously, you have to make sure that result was pointing to 19. Its next should be, or if you see what we have done in this, we are handling the next node. Eventually the resultant linked list that we want to give should be a single linked list like this. What we are trying to do, that result is pointing to A, then result dot bottom, I am attaching the next just greater node to its bottom pointer. So we are handling, instead of using next pointer, we are handling it using this bottom pointer. You can do it anyway. I just chose to take bottom pointer. So now 19 dot bottom should be pointing to, this is what is happening, merge of, now what is the new node, 22 and 28. Based on the comparisons, which is smaller, A is smaller than B, so result is going to point to 22. Again new node result will be created and it is now pointing to 22. So A now should be pointing to 50 and the comparison should be between 15 and 28. So 19 was pointing to this merge, and now this merge, whatever resultant it got, what was the result of these two? So its answer came out to be 22. So 19 is actually pointing to 22. 22's next is pointing to, now my merge is being called for, A is what, 50 and B is what, 28. Got it? Now you do the same comparison. Maybe you go to the else case. Now you go to the else case. Why? Because B is smaller than A. In your else case, again you do the same thing. Now your result will be pointing to B, and result is pointing to B. B, if my result is pointing to B, I should move my B to the next pointer. Now my B is here. B equals to B dot bottom. Fine. And then again, you should be calling your merge function, provided that you also make sure that you are forming the link from the previous answer. That is, we are doing it here also, but I have not mentioned in the code. We will see this you can understand as a pseudo code. Then I am making a call to merge, and now my B has been updated. A will remain as it is. Now B is this. We are doing the same thing in both the comparisons. Okay. Now so after 19, I was making its bottom pointer point to 22. 22's bottom pointer is pointing to which node? Which was smaller out of 35 and 50? Obviously 35. Did I take 28 into consideration from 22? Okay, B is still here. Now my A was at 50. I compared 28 and 50. So my 22's bottom will be 28. Then my B moved to this 35. Then I made a comparison between 35 and 50, which was a smaller one, 35. So 28 dot bottom will be pointing to 35. Okay. And when it was smaller, I moved my B to the next pointer. I make the comparison again. Now let's move to a comparison. Which one is smaller out of these two? Obviously B. So I must have gone to the else case, correct? Now from my else case, the previous what I had in my list, which I was actually apparently my singly linked list, now 35's next should be pointing to 40. It is simple merge sort of like we did in array. The only difference is here we are handling the nodes. The only difference is that, and you have to just take care of the links that we are using. Okay, so now it is pointing to 40. Fine. So B should be moving to its next pointer. Now my B is at this and A is still at 50. Which is the smaller of these two? 45. So 40's bottom should be 45 and B moves to null. So in my merge function, my condition should be if either my A is equal to null, then you should be returning B, correct? And if my B is equal to null, then you return A. I'm not writing it entirely because I will move to the code. I'll do the dry run, then you will be able to understand. Okay, now in this case, when I returned 45, what you see, your B is pointing to null as of now. If your B is null, that means you are returning A. So the node that you are returning, that will be attached to the bottom pointer of your last node. So 45 is now pointing to 50. So now can you see that we have actually converted this, flattened these two linked lists which were looking like this. 19 and 28 were head of the two simultaneous linked lists, we can say. We made a comparison by using this merge function, which is taking a new head of this list and a head of this linked list. And based on the comparison, I am attaching my node to the bottom node of this. Let's say this is my newly formed singly linked list, whose head I will finally return in my resultant. Right? So what we wanted to do, 19, this is 19, 19's next is pointing 22. Now you can see that if I just talk about, now if you can do this for two linked lists, you can do for the remaining part of this linked list as well. Why? See, this thing we did for two linked list. If I want to repeat the same scenario for the other things, what I'm going to do, I'm going to make a recursion call. In my recursion, I am passing this head. Whatever I get in return, I will be making. Now you assume this was my resultant linked list. Its head I will be returning to my recursion call, whichever call made call to this merge function. So this ideally returned me the head of this final singly linked list. Now this final singly linked list will make its comparison with this remaining linked list. Now its new head will be 10 and its head will be 19. So just imagine 10's next is pointing to 19, but 10's bottom is pointing to 20. Now consider it as another linked list in which this is your A, this is your B, and you are doing the same comparisons all over again. That can be handled using recursion. That faith you can have, right? When I show you the code, you will understand how this is being handled. But let's understand the logic behind it. If you guys are having any doubts during this, let me know, write it in the chat, okay? Try to understand. Now the next scenario will also be same. You make the comparison between 10 and 19. 10 is smaller, then 10 will be added here. Its bottom will be pointing. Now A will move to its bottom pointer. A is right now pointing to 20 and B is still at 19, right? Which out of these two is smaller? Obviously the node pointing to 19. So 10's bottom will be pointing to 19. And B will move to its next bottom pointer, which is this. Now you're comparing 20 and 22. So 19's bottom will be pointing to 20. Okay, and A will move to null. So as in when my A becomes null, I told you we are returning the other linked list head. So right now my B is pointing to which node? 22. So that means if I return B and attach my B directly to the last node of this singly linked list, so B will come along with all the attached nodes at its bottom. You getting my point? So all the nodes which are present within B, means after B dot bottom dot bottom dot bottom until it becomes null, that is coming along whenever we are attaching this node to the bottom node of our last list. So 22, its next is 28, its next is 35, its next is 40, its next is 45, and its next is 50. If you closely observe, we have actually merged these two lists in which A was initially 10 and B was initially 19. And this was already ensured since this was a resultant of previous two lists that we took from here, right? So this was already in sorted order. Now we were actually sorting this into one single linked list. That is why it is always ensured, means you don't have to worry about whenever we are attaching this 10 20's dot next to 22, that what we were doing here, all the subsequent nodes after 22 are going to be greater than that only. That means they will be in sorted order, correct? Now this is your new linked list. Its comparison will be done with the leftover linked list, which is this. Now basically your question has come down to merging 5, 7, 8, 30 with 10, 19, 20 and so on and so forth, and finally you will get the resultant like this, which is 5, 7, 8, 10, all the nodes in a single linked list in sorted order. Got it? So let's have a look at the code, and then you can understand what is typically happening in it. See, this was the function that was given in your class GFG, okay? Node flatten, you were given the root node, which was pointing to 5. This was the root node, fine. What is our base case? What should be our base case? Basically, we are moving towards these nodes which are pointing. Let me just take the code and then I will tell you properly. So this is your code, okay? And let me quickly take your test case again, so that there will be no doubts left. Okay, fine. Okay, what is happening? This function is making the recursive calls. This function is ensuring that you are doing these things recursively for these nodes. Initially, your root node is pointing to 5. So node root, this is your root node which is pointing to 5, correct? The base case condition is ensured that you are trying to move to the next of these nodes. Assume this as only linked list, right? You want to hit the head of all these linked lists which are having their bottom branches. So what my target is, I go till the end of the linked list via its next pointer, and then I pick the subsequent linked list having its bottom branch and come and take the second last linked list having its bottom branch, and I'm merging them. Then whatever result I get, I go ahead and do what? Root dot next. First, now let's understand from here. This is your base case condition. Root is null. No, root dot next is also not null when my root is pointing to 5. Let's see, 5, 10, 19, 28. Okay, this is your root node initially. This is your root. Now root dot next equal, you are again making a call to this flatten function such that you actually want 5 dot next is making a call to flatten, and what is it passing? It's next. What is 5's next? It is 10. Okay, then this flatten, whatever result you get, okay, you do the same thing. What are you going to do? Its next is pointing to, you are making a call to 10's next, which is 19, okay. Then again you are making a call to flatten of 18 na, yeah, 28, sorry, it is 2, flatten of 28. Now wait, when you have made a call to flatten of 28, your root is 28. Your root is null? No, but root next is null because 28 next is pointing to null. So in that case you are returning root. Okay, what was the root? 28. So 28 was returned to the function that made a call to it, right? That means root dot next, 19's next, this whatever this function made a call, okay, whatever root for it was its next is now pointing to 28. Got it? So 19 dot next is pointing to 28. That has been clearly established. Fine. Now what you are doing? You are going to do this thing. Root is whatever, now 19 has its own branch. Now let me add the branch of 19. What was the 19th branch? It was pointing to 22, further pointing to 50. Okay, 28 was pointing to 35, its bottom 40, its further bottom 45. Now see, this root, what I am trying to do, I am updating this root by whatever root I get from the merge of these two linked lists. You getting this thing? This is the next step of my recursion call. Once I get an answer for this root dot next, okay, the base case was if either your root is null or root dot next is null, you are returning root, okay, and then you have established a link via next pointer to that particular node. Now you have gotten two nodes, okay, the head of two linked lists having their bottom branches. Then I am making a call to merge function in which I am passing this root. What was the root? 19, and its next, which is 28. Make sure next pointer, not the bottom pointer. Now merge of 19 and 28 will do its task, and it merge function, now if you see, it is exactly what I showed you. So merge function finally will return me the result, which is actually the root of the singly linked list that I will get in the sorted order. So the sorted order linked list for this 19 and 28 branches and everything, what I'm going to get? I'm going to get its resultant as 19 only. You getting it? 19 pointing to what? Because it is the smallest one. 19 pointing to the one we saw here. 19, 22, 28, 35, 40, 45, 50. This linked list head will be given to root, and you return root from here. So this root is recursively now returned to the function which made a call to it. So this root, actually 19, is being passed to flatten of 10. So one thing we have ensured is that now 10's next is pointing to 19, which has its subsequent branch, and that branch is actually now a singly linked list in sorted order. So this 10's next is pointing to, let's form the bottom branch of 19, which is entirely 19, then 22. This dry run, once you understood the logic, this dry run you can easily do, but I'm trying to do it as much as we can here in the class so that you'll have no doubts. 19, 22, and then I have 35, then we have 40, I think 28, I'm sorry, 19, 22, 28, 35, 40, 45 and 50. Fine. Now what is 10's bottom? 10's bottom was 20. Now a merge will be called for this as your linked list, where your A will be 10 and B will be 19, and same thing will happen. So this is how recursion is taking place. And merging, you already know, merging part is very simple. You're just making sure the smaller one is being attached in result dot bottom, and then you are making the merge that I have already discussed with you guys. Fine, based on whichever is smaller. A is smaller in this case, so result is pointing to A, and result dot bottom will be pointing to merge of this A dot bottom, which is 20 and 19. So 10's next will be pointing to the smaller of these two, right? That's how it is happening. And then next comparison will be made between 10 and 22. This will be B, this will be A. So that's how you will get your entire answer. Do you guys have any doubts, guys? Let me know if you guys have any doubts in this question. I'll just show you. Got it? So just let me know if you guys have any doubts. I'll take up your doubt. Otherwise, we are done for today's lecture. Coming on to the time complexity. So as you see, we are actually going through each and every node of this given linked list, whether it is a bottom branch or it is the next branch. So typically it's nothing. It is completely proportional to the number of nodes that are present in your linked list. That is big O of how many nodes are there, total nodes, no matter how many are there. And let's see what is given as your number of linked list. It's given n into m, where m is what. I'm just trying to figure out if what should I write as n. If they say that total number of nodes is n, so I'll write big O of n. Linked list of size n, node represents a sub-linked list. So basically n, I think n only counts for these 5 nodes. Okay, I think so. Represents a sublink and contains 2 pointers. So basically it will be the sum of all the nodes that you have in the bottom branches as well as in this singly linked list also. Okay, so that will be, if I say these are m number of nodes, so total n plus m you can say. Okay, So this will be your time complexity, that is equal to the total number of nodes present in your linked list. I'll write it this way. We go total number of nodes in given linked list, including sub branches. Okay, no extra space taken, so space complexity will be big O of 1. That's all. Shall we wrap up today's lecture? If there are no doubts, I will just wrap it up and see you all in the next lecture, everyone. Till then, try to do it yourself. Just try to understand the logic and you can code it on your own. Fine. Okay then guys, see you all in the next